Hello everyone. In this video, we are going to look at another example of data cleaning. So now that we have been able to understand different levels of data cleaning, this example is going to also feature how we would deal with missing values in different scenarios. So before doing anything, we always import the modules that we're going to be using. In this example, we are going to use Google Play Store data from Kaggle.com. So if you want to find that data on Kaggle website, you can use this link. So once we run the data and we see it as a pandas data frame, we see here, so pay attention that I changed the app column to be the index. And we see that this data has a couple of columns and some more rows. We can go ahead and sort of like get to know the data a little bit better. We have 10,000 rows and 12 columns. So the way we get to know a new data is different based on numerical attributes and categorical attributes. So here, that's because of that, I have separated the numerical attributes and categorical attributes. So once we run this, now with the numerical attributes, the simplest way to get to know a new data or a new column is just use the function describe. And we will see that here, the mean and standard deviation and minimum and maximum of the possibility for rating and reviews. We could do even something better. We could look at the histogram of numerical attributes. So once we look at the histogram, not only we sort of see the summary of this column, we all can see much more visually of where the data is for this data. So we can see most of the data ratings are around 4 to 4.5, and then there are so many little before 3. So we get a very good sense of this column. What about reviews? Most of the reviews are don't have reviews, and there are some that have so many reviews. So most of the applications don't have any reviews. But about categorical attribute, the way we go about doing categorical attribute, we use a function unique, and the function unique allows us to see the possible values that the categorical attribute have. So once I run this, now I can see the possible values for column category, and all of these are the possible values that the column category can have. And then we'll look at the possible values for size, and there are so many of them. And then we look at possible values for the number of installs and type, free, paid, and missing value, and so on and so forth. So once we look at this, now we sort of see some opportunity to be cleaning this data better. Even though this isn't a string, but we can see that the size could be a number. We could clean this column so we re-represent the data as numbers here. So that's what we are going to do here. So we are going to clean size. So the way I'm going to do this, I'm going to create a function that I'm going to apply to this column later. And I'm saying, if we go back here, we see that there is a case varies with device. So this is one of the possibility that there is no numbers. And other than that, there is no other just strings. There is always a number here. So if that value is that, which is varies with device, we change that to a null value or a missing value, np.nan. But if it is not that, then we check if it's M or K. So as you know, M stands for megabyte and K stands for kilobyte. And we know the relationship between them. Every megabyte is 1/1000th of a kilobyte. Or if you want to switch megabyte to kilobyte, you basically multiply the megabyte by the value of 1000. So if we see a value m at the end of the string, so when we say -1, it starts counting from the reverse side. So if we say -1, it's going to grab this part of the string. So if it's m, we basically just return that. Return everything else as the number, which is the megabyte. If it's not that, if it's k, so it's either m or k, we multiply that by 0.001 and translate that into a megabyte, and then we return that value. So now if we apply this function, we will get to have the size as a column, a numerical column. So we define the function, and then we apply that to this function, to this column. And we get to change all of those values to a numerical one. And why don't we go ahead and also apply this? So once we do this, this is only spitting out the result series, this series that is resulted from this apply. But we want to keep that as our new size. So we assign that to the size, and then we can go ahead and now also look at the histogram of this column. That is a numerical column now. So we'll see most of the size are less than 10 megabyte. And then we have some that can maybe even go all the way to around 100 megabyte. So now our numerical attributes also have size. We can go ahead and also use the function describe. And the size, the mean, standard deviation, and all of those are also reported here. Another opportunity we have is clean price. So if we look at the possibility of prices, we see that it's either 0 or a value with a dollar sign. So we could also make this a numerical attribute. We just need to get rid of these dollar signs. So the same way as we did for size, we apply a function to the price. And here, because the function is a little bit less complex, we go ahead and basically do a lambda function. We say return the float of the value, whatever you have after the first index. So whatever you have after the first index are these values, these values, these values, so on and so forth. And if the first one is not dollar sign, return this. If it is the dollar sign, just return the value. And there's only one case that was the case, and that was when it was 0. So once we apply this, we sort of get rid of the dollar sign for that price. And now we can go ahead and also draw the histogram. We can see that most of the apps are free because they are 0. Most of them are free. So now we can go ahead and add the price to another numerical attribute, and we can put together the numerical and categorical attribute to sort of like have our clean data frame. So this is appdf. This is our new cleaner database dataset. So now let's go further and see if there are any missing values. The way you can quickly check if your data has any missing value in pandas is to use the function isNaN. Basically, the function isNaN will spit out a series or a data frame. If it's a column, if it's only one series, it's going to spit out a series. If it's a data frame, it's going to spit out a data frame. And it tells you for specific cell and column versus specific row and column, if there is a missing value there or not. So basically it's going to be Boolean data frame. So everything is a Boolean here, and we can see that, for example, this one has a null value. So this is pretty nice, but it's hard to eyeball this. It's better to sort of like report out the number of missing values. So here we are doing a loop over every column. So we want to see the number of missing values for each column. And we create a Boolean mask using the isNaN function for each column. And then we only keep the ones that have missing values, and then we count those numbers by length. And then we report this out. So once we run this, now we will know that the rating, size, has significant number of missing values, and category and type has 2 missing values. So one of the first things you always need to do when you understand your data does have missing value is to check what type of these missing values you have. And the most important part of figuring that out is to see if there is a specific propensity between a row having missing value based on the other column. So basically you want to see if there is a pattern in your data about a column or a row having missing value for a specific column. The way you can go about doing that, you can really take advantage of bar charts. So here, bar charts for categorical attribute and histogram for numerical attribute. So for categorical attribute, what I've done here, I have grabbed the missing values for rating. You see the missing values for rating, and this is those missing values. And then what I'm doing here, I am plotting every other columns, not this one, every other columns, and I put that next to plotting the same columns for the whole data. And what I do for numerical attributes, I do the same thing, but this time I'm using histogram. So let's take a look at it and see what that means. So once we run this, now we can, for example, see among all of the missing values, that rating missing values, there is this pattern in the data. And the pattern that we see is very similar to the pattern we see in all of the data. So for example, this family, which is the highest one, is also a highest one in here. And for example, this travel and local is also, no, my bad, tools is also a higher one in there. So we can see that there is no specific propensity of missing value happening because of the column category. We could check the same thing about the column installs, and we can see that we don't really see a pattern there. Or about the type, free or paid, you can see it's pretty much the same propensity. And then about the content rating, you can see they are almost identical. And about rating, I mean, these ratings are, this is missing value because all of them are missing value, so it's good that nothing is here. And then we look at reviews, very similar. We look at size, again very similar. We look at price, very similar as well. So we conclude here that because we were not able to find a pattern based on the other columns in this data to show us that it's possible to sort of like predict a column being missing in the for the rating column, we assume that these missing values are completely at random, or MCAR. That was all our investigation about. We wanted to figure out what type of missing value that was. So we can do the same thing for size, but do you remember we ourselves intentionally change size to missing value. When we were cleaning size, every time there was varied with device, we change that to missing value. So we know why there is missing value there. So we don't really need to investigate, since we know that, and because we preferred having numbers. We wanted to have numbers instead of like categories. That's why we assume that the size varying the device is completely random, and that's why it's also MCAR. Those missing values are also MCAR. So for category and size, there was only one missing value for each of them, and because of that, we can also assume that there is no pattern, because one missing value for each, there cannot be a pattern there. So because of that, we also assume that those are also MCAR. So now that we know all of the missing values in this data is missing completely at random, let's take a look at two possible analyses, and we see how we go about dealing with these missing values when we want to do specific analysis. So for example, in analysis 1, we want to examine the relationship between rating and review. We want to see if there is a connection between the rating of an app and the number of reviews the app have. So one of the ways to go about this is to do a correlation analysis. So once we run the correlation analysis, we do see that there is a very low correlation between them. So there is not really a relationship between them. And we can also do this by first dropping the missing values and then doing this. So the way you drop missing values in pandas is you just say drop NA, and all of those missing values that has missing values will be dropped. And if we do the correlation for this, we get the exact same values. And what that tells you is the fact that the function core in pandas automatically drop missing values before applying the correlation formula. So that tells us that the good way, or what pandas developer thought about good way of dropping or dealing with missing values when you want to examine the relationship between columns, is dropping them. And of course, the assumption there is that those missing values are MCAR. There is another approach we could do to go about this. We could use scatter plot to see the relationship between columns. And it's very simple to come up with scatter plots with pandas. You just say that plot is a kind, and you will have X and Y. And then once you run this, you will see that because the values of some of the reviews are so much, we don't really see any relationship here. So to rectify that, we could do a log transformation of the reviews. So if we do that, now we will see a relationship here. So we can see that for some apps, the number of ratings is correlated with the number of reviews, or ratings is correlated with, but for some they are not. So there is not that relationship as we saw in the correlation analysis. So we could also do this by dropping the missing values first. So we drop the missing values and then do the this plot, and we'll see exactly the same plot again. And what that tells us is that pandas also drop the missing value when you want to do a scatter plot. And it is the correct way to go about examining the relationship between two attributes, and in your attributes you have missing values. So let's look at another analysis, possible analysis. So we want to use k-means to group the apps into 4 clusters based on only the numerical attributes. clustering algorithms are something that you will learn more in the future. This is not a part of this course, but there are so many things about these algorithms that you will get to learn. But here we just see a very quick example of how clustering algorithm will function. Basically, you want to group your data objects, which in this case are applications, mobile apps, into clusters. And there are algorithms to do this. So what we're going to learn here is really if our data has missing values, how do we deal with them when we want to do clustering? So here I want to only work with by numerical attributes, because that's the purpose of the analysis. So I only keep the numerical attributes. So these are all only the numerical attributes, and then I fill out the missing values with the median value. So I have a question here. I'm filling out with the median of each column. Why not use the mean? Stop this video before continuing to watch, because I'm going to give the answer. So the reason is, if we use the mean, for example, let's talk about this one. If we use the mean, these extreme values are going to have a pull on these, values. Because of that, we go with the median, and the median gives us a better representation of the centrality of the data. That's why we most of the time use median to impute before doing analysis. But why don't we drop these values and we are imputing? So when you're doing clustering, basically what's happening is you are going to see the apps that are more similar to one another and are different from the other ones. So if we were to drop these attributes, we would drop some of these application data rows, then we wouldn't know what cluster they are a part of. So the way we deal with this, we impute values here in a way that it's not going to affect the result of the clustering that much. If you impute the centrality of each of those attributes, then this imputation is not going to push the attribute or the data objects with missing values towards any of the clusters. It's just going to remain that attribute. For that attribute, it's just going to remain sort of like a neutral, because you've put the centrality of the data there. So that's what we do. The way you go about this, you basically use the function fill NA, and you say, I want the median of each of those columns to be used. So once we run this, now we don't have any missing values in our data, because we fill them with the median of each column. And before you do a clustering algorithm, you will have to standardize your data. And the reason you do that is because you don't want the columns that have higher scale have more weight in your result. You don't really need to worry about that in this course. I'm just showing you this as an example. So once we run this, now our data is standardized, and once we describe, we'll see the minimum and the maximum of all of our data is 0 to 1. That's basically what standardization is. We rescale the data in such a way that the minimum is 0, the maximum is 1, and the rest of the data is shown also there in the scale between 0 and 1. So to use a clustering algorithm, I'm using the sklearn module, and I'm using the k-means clustering. It's very simple. So you basically say I want to use a k-means cluster with 4 clusters, and I'm fitting the standard data. Once you do this, now it thinks a little bit because it's processed the algorithms. But once it's done, you will have 4 clusters. So these are the apps that are in cluster 0. We have the report here, and the cluster 1 and 2 and 3 also is shown here. It's pretty overwhelming because there are so many rows here. We could do this a little bit better. So these are the members. These are the apps, and these are the clusters. We could add that to our attribute, to our data. So these are the clusters based on this clustering algorithm. And now we can see based on these clusters what are the changes with all of these attributes. So once we run this, first you will see each cluster based on each category, and so this is based on each category, and then based on number of installs, based on the type of app, paid or unpaid. We will see that for these we don't really see a very much distinction between the clusters, cluster 0, 1, 2, 3. Content rating, we don't see much of a distinction between them here either, but once we get to the numerical attributes, we see those distinctions. So cluster 1s, the ratings are less than 3. For cluster 0, 2, and 3, the ratings are higher. But there might be other things that are different here, but the frequency is more. But for the size, we can see cluster 2, the size are higher, and then we have cluster 0 here, the size are in between, and then cluster 3 and cluster 1, maybe they are separated by. So before continuing to watch this video, think about why there were so much distinction between the numerical attributes for each cluster, but there were not enough distinction between the categorical attribute. Before watching this video, think about this a little bit. So the reason is very simple. It's because we use the only numerical attributes to do the clustering. Do you remember? We only use the numerical attributes. And of course, because of that, those numerical attributes will have significance in those differences. And this analysis tells us that there are not a lot of relationship between the numerical attributes and the categorical attributes in this data. But what we wanted to learn here really was when you want to do a clustering analysis and you have missing values in your data set, and those missing values are missing completely at random, the best way to go about this would be to impute those missing values with a central tendency.